The sediment cycle, where it comes from and where it goes. The marine sediments, they show a great variety of what their source is. We're going to talk a lot about the different sources, but also how they're transported and where they deposit. Um, so there's a lot of debris from wearing down of the continents and volcanic mountains. There's also, as we just talked about, sediment can be derived from organisms, from their shells or other organic matter. Minerals can also just precipitate right out of seawater, right? So halite crystals, that wasn't transported in from anywhere, that just formed in the ocean. You can also get volcanic products like ash and pumice and things like that raining out of the atmosphere. So all of this matter is transported in various ways depending on its source and what size it is. It's deposited in different areas and subsequently undergoes diagenesis and redeposition to various degrees. What that means, diagenesis, is becomes a rock, right, or changes from a soft sediment to a hard solid structure, right, and reformation in various places. All right, so first, let's talk about the sources. Where does the sediment come from? Most of the sediment that ends up in the ocean is fluvial. Fluvial meaning comes from rivers. So that's going to be that lithogenic sediment that was eroded from the land, transported down the rivers, and then eventually deposited in the ocean. This is an image actually of the largest river in the world that deposits the most sediment of any single river, and that is the Amazon River. So here you can see Brazil or the green land, the Amazon River at the bottom. That river is bringing so much sediment out into the Atlantic Ocean. You can see that the Atlantic Ocean is just colored this like mud color, this brown, because that sediment is just so um, at a high concentration, so turbid. And then eventually you get out into the clear blue ocean. And even though the Amazon is the biggest river in the world and contributes the most sediment to the ocean, other rivers also contribute a fair amount of sediment to the ocean. For example, here you can see the sediment plume coming off of the Mississippi River in Louisiana, going out into the Gulf of Mexico. Another river as an example, another river and another river as an example, right? You can see that where rivers meet the ocean, the water turns brown, right? That's why our water is brown because we're in between the Altamahans and the Satilla rivers. Um, I love this map. This map is showing the amount of sediment that is coming off of different regions on land going into the ocean, and the amount of sediment is signified by the size of the arrows. So, as I said, rivers dominate sediment delivery to the ocean, which means that the regions of the ocean that receive the most sediment are those that are at river mouths. So we're going to get a ton of sediment deposited on the Georgia coast because we have a lot of rivers draining the Appalachian Mountains, depositing sediment on our coastline. You're also going to get a lot of sediment in the tropics where there's mountains. So the Amazon River, its tributaries start in the Andes Mountains. So you get a ton of sediment there. And then you'll see over in Southeast Asia, all that blue area, that's draining the Himalayan mountains, these huge mountains. Southeast Asia is a tropical environment, lots of rain, lots of heat, lots of humidity. That's all perfect for breaking down those mountains, breaking down those rocks, weathering those rocks, turning them into transportable sediment and then delivering it to the ocean. So that is where you're going to get most of the sediment deposited in the ocean in front of those river mouths. Coming back to this image here, right, you can see, as we just said, um, our continental margin here in Georgia, also in the Gulf of Mexico, where you have the Mississippi River, we're getting a lot of sediment there. The north side of South America, you get a lot of sediment because of the Amazon River. And then obviously in Southeast Asia, you get a ton of sediment from those rivers that are draining the Himalayan mountains. Turgidous sediment, meaning sediment coming from land, it doesn't just have to be transported by river, though. It can also come down through glaciers. So delivery from glaciers and icebergs is also important, especially at high latitudes. And if you look at the seafloor and look at how much of the area on the seafloor contains sediment that was ice transported at one time, it's about 20% of the entire seafloor. Okay. And if you look at the mouth of a glacier, it looks very similar to the mouth of a river, right? It's a different transport mechanism. It's ice rather than water, but it's scraping up and bringing down similar loads of sediment into the ocean and depositing it there. So here's an example of glaciers in the Copper River Delta, another one in the Labrador Sea coming off of Greenland, right? And you can see those sediment plumes. They're more white than they are brown because they come from glaciers rather than rivers, but you still get a lot of sediment coming down. Coming back to our sediment deposition on the seafloor, you can see We get a lot of sediment around Antarctica and in the Arctic Ocean, right? And all of that is coming, or not all of that, but the vast majority of that is coming from glaciers. So we can get terrigenous sediment from rivers and from glaciers. We can also get it from just wind, which we call aeolian sediment deposition. So wind can move really fine material great distances. Wind is not going to be able to pick up big stuff, right? It's not going to be able to pick up coarse sand and move it great distances, but it can pick up silt, it can pick up clay and move it all around the world. So even the most remote parts of the ocean, far away from any landmass, can still get aeolian clay. And if we look at this image, the colors show how much aeolian dust is deposited on the ocean floor. And if you look at the North Atlantic, where we are, you can see the color is mostly like yellow to light green. That means that we're getting about 10 grams per square meter per year. To put that into context, that's about 2 teaspoons, right? So it's really not very much. 2 teaspoons of dust on every square meter every year. It's not a lot compared to, say, rivers or glaciers, but it is this constant delivery of sediment to remote parts of the ocean that otherwise are too far away to receive sediment, say, from rivers or glaciers. Right? And again, clay can move long distances. If y'all remember the dust storm that we had back in 2022, there's another one actually predicted for this year. I'm recording this in 2025. Um, this is what Georgia looked like back in 2022. This dust from that dust storm came all the way over from Africa, right? It transversed the entire Atlantic Ocean, coming over from the Sahara Desert, whipping up through the Gulf of Mexico before coming back to us in Georgia. So the same dust that blanketed our cars and our clothes and our throats also blanketed the ocean and deposited that clay in the abyssal plain. So we've talked about rivers, glaciers, wind. Finally, we're going to talk about volcanoes. Um, just like aeolian clay, right? Volcanic ash is really lightweight, low density, and it can travel all over the world, right? A single volcanic eruption can send ash from pole to pole, from east to west, all over the world. So volcanic ash and volcanic deposits are really important, especially on active margins. And again, the fine ash can be transported by the wind great distances. So any volcanic material that is large enough to deposit quickly, we call that volcaniclastic material. Any volcanic material that is small enough to be transported globally, we call that volcanic ash. So extrapolative thought. Can you apply what you just learned? Why is most of the aeolian sediment found in the northern hemisphere? Notice the North Atlantic and the North Pacific and the Indian Ocean, they all have quite a bit of aeolian wind blown sediment. You go down to the southern hemisphere and it's mostly dark blue, right? So why is there more aeolian clay being deposited in the northern hemisphere compared to the southern hemisphere? I also want to know, can you recall, what is the scientific term meaning related to rivers? So river sediment is called what? And what's that word when it's related to wind?